Hi everybody, this is Sam with Python Basics, and in today's video we're going to be taking a look at the Monty Hall problem. So I guess it was a month ago. I did not think it was that long ago, but I posed this in the poll of who all has seen the Monty Hall problem. So if you're new here, thanks for joining us. This is what we do. We do micro videos. So what is the Monty Hall problem? So what this is it's actually a little bit of a math and a little bit of probability. I guess probability is math. But all right, so there was a game show back in the 60s, I believe. And the contestants had 3 doors. And behind one door, there was going to be a car. And behind the other 2 doors, there were goats. So what the premise of this problem is not only would you then pick a door, you would be then given the option to switch doors. So, all right, I'll say that again. So you would be asked to choose a door. You didn't know which door had anything behind it until later after your choice. So what the host would do is the host would then open up one of the doors that had a goat behind it. And so my first experience with this problem was when one of my children was in an 8th grade math class and the math teacher had them do this longhand. Well, then I was invited to come through and write a program to verify this. So what I did is, and shortly in a little bit, I'll put up the link to the video so you can go back and look at it, but I'm going to show you the results. So, but again, what the premise is you pick a door, then the host will show you one of the doors that has a goat. Then you get asked the question, do you want to keep your door or change doors? Well, at first look, you think, well, all right, I have a 50-50 chance, so I'm going to stick with my door. Well, that is actually inaccurate. You have, if you switch, you have a 2/3 chance of winning. But if you keep your door, you only win 1/3 of the time. So now let me actually show you the results here. So I went through and I retooled this and I rewrote this a lot. But I'll put the link up in just a second. So if you play the game 5 times, if you switch, you win 80% of the time. But as you'll see, the more times you play, the closer it approaches 2/3 and 1/3. So the way I have this laid out is the output is games played, switch wins, switch losses, and then no switch, and so on. So at 5, it's 80 and 20, then 70 and 30, and where you really begin to see this is once you approach 100, 1,000, 10,000, 100,000, and 1,000,000. So as you can see, you win 66% of the time. So mathematically, and proven here by this logic that is being written, if you switch, when you get shown a door, you want to switch, and you will win twice as much as if you stick with your same door. So now I'll go ahead and put the link up to the video up here, right up here. So go ahead and check that video out. And if you have any questions about it, go ahead and drop them in the comments below or jump over to Discord and make sure you're hitting that like button, subscribe button, and the notification bell because I don't want you missing any of these videos. And maybe in a week or so, I will drop this script into Github so you can look at it, experiment with it, and just kind of play around with it. But as always, guys, thank you so much for watching. Stay tuned, and we'll see you next time. Bye, guys. Hey, guys. Thanks for joining us today. I hope you really enjoyed today's video. And if you haven't, check out this video right here or this one right down here. And most important, make sure you're hitting this subscribe button and the notification bell. Thanks again for joining us, and we hope to see you next time. Bye, guys.